Now let us see the enqueue operation. As we are implementing queue by using arrays, we will assume the maximum size of the queue is 5. As the array index starts from 0, initialize the front and rear pointers to -1. From the front end, we can perform the deletion. From the rear end, we can perform the insertion. So this is the initial representation of empty queue. Front and rear are set to -1. There is no element in the queue. Now let us try to insert the elements one by one into the queue. Now we are trying to insert the element 25. To perform insertion, we need to check the condition rear equal to maximum size -1. Rear here is -1. Whether it is equal to maximum size we have taken as a 5. So 5 minus 1, it is equivalent to 4. Whether -1 equal to 4. No. So we can perform the insertion as the queue is not full. Now, where we need to place the element 25 into the queue. For that, first you need to increment rear by 1. That is -1 plus 1. Rear will become 0. Now in the 0th position, we can place the element 25. In the 0th position, we can place the element 25, and now the rear value is 0. As well as front is always pointing to the first element in the queue. So we can set the front to 0, because when the front is having -1, there is no use. It should always point to the first element of the queue. Now set front also to 0. That means after inserting the first element, front and rear both are set to 0s. Now let us try to insert one more element into the queue. That element is 10. Now we are trying to insert 10 into the queue. So again, the same process we need to repeat it. So rear is how much? 0. 0 equal to 4. No. So we can perform the insertion at where we can increment rear by 1. 0 plus 1, you will get rear as 1. That means in the position of 1, we can place the element 10. Now rear is pointing to 1. There is no change in the front. Now let us try to insert one more element into the queue. That element is 45. Now again, we need to repeat the same process. That is, check rear with maximum size. So what is rear now? 1. 1 equal to 4. No. Increment rear by 1. Now rear will become 2. In the position of 2, we can place the element 45. Now we'll try to insert one more element, 75. Now what is the value of rear? 2. 2 equal to 4? No. So we can perform the insertion? Yes. Now what we can do? Increment rear by 1. Now rear will become how much? 3. Now in the position of 3, what we can do? We can place 75. Now let us try to insert one more element, 86. Now what is the value of rear? 3. Whether 3 equal to 4? No. So can we perform the insertion? Yes. Now what we need to do? Increment rear by 1. 3 plus 1, you will get 4. Now in the position of 4, what we can do? We can place the element 86. In the position of 4, we have placed the elements. We have placed the element 86. Now we will try to insert one more element into the queue. What is the element we are trying to insert here? 100. Now before inserting 100, what we need to do? We need to check whether the queue is full or not. So what is the rare? 4. What is the maximum size minus 1? 4. Both are equal. Can we perform the insertion? No. So what we can say? We cannot perform the insertion as the queue is overflow. Now, we cannot place 100 into the queue. So this condition is called as overflow condition. Now let us see the function for Enqueue. So whatever may be the operations we have performed till now on the queue, they are going to be represented in the form of a function. First, what is the condition we are checking every time while performing the insertion into the queue? We are checking rare equal to maximum size minus 1. When the rare equal to maximum size minus 1, we cannot perform the insertion as the queue is already full. Next, if the condition is failed, then we are reading the element to be inserted into the queue. What element we want to insert? After reading the element, what is the first step you need to perform? Increment rare by 1. Rare equal to rare plus 1. In the position of rare, we are placing the element. And what is the one more condition we need to check? If the front is minus 1, set front to 0, because front should always point to the first element of the queue. So whatever may be the functions, whatever may be the operations we have performed on the queue during Enqueue operation, same thing are represented in the form of a function.